What we're going to do today is we're going to talk a little bit about the procedural nature of Houdini and how procedural modeling kind of works versus the regular concept of just moving stuff around with transforms till you get it where you want it. Now, I have a course or a lesson that'll be up just after this too, where we'll start to talk a little bit more about how we can build those procedural models into digital assets and start to use them in other applications through Houdini Engine. So this is really sort of the foundation of where you want to start to begin to build those digital assets. This is going to give you just sort of a concept of what parameters you can use to adjust your models dynamically and how you can use those later. So stick around if you want for the second course, and we'll take some of that stuff into Maya, and we'll start looking at how we can use Houdini Engine inside Maya for the procedural nature of the assets that we build in Houdini. So this is me and my dorky little thumbs up photo that they make me use everywhere. I'm John Moncrief. I'm a curriculum manager for Pluralsight. Pluralsight used to be Digital Tutors, as some of you know. Pluralsight has a much larger division that also handles IT, dev, programming, things C++, Python, all that stuff, all the way down to how to configure a Linux server in a massive whatever. We are the creative design and engineering branch of that larger online training company. And today, we're here to talk about the creative stuff and Houdini very specifically. So let's get started. Whenever I start to build any kind of procedural model or start to look at anything that's going to be procedural in nature, I always try to collect as much reference as possible. If you can get AFK, away from keyboard, to do it, like if you can go out into the real world with a camera and start sketching some things or taking photos, trust me, you'll be better off for it. I was able to get what I needed for this course pretty quickly just by looking online. What we're going to do is we're going to try to build a dynamic bridge system. So we're going to have all kinds of fun little sliders that we can use to build this bridge. But what I noticed when I started studying bridges and kind of collecting the reference for those bridges was just exactly how modular bridge construction actually is. You see these repeated elements over and over and over again, which leads it to be a perfect concept for using to create in a procedural way. Because you only need to define certain parameters for certain pieces of it, and then you can just repeat them over and over to get the look of the bridge that you want. Now, another thing that I do whenever I'm building something procedurally or something in Houdini is I always look up whatever the object is and dimensions, because it gives me an idea of kind of what structure I'm going to be working in and how big these things need to be inside the actual interface in Houdini. So this is just some more of the reference that I was gathering when looking at how I want to build my bridge. And the other thing is, you should know your inspiration. Like I said, getting away from keyboard and going out into the real world is a good way to start collecting some of that information and some of that reference material. I live in Oklahoma City. Nobody? Really? No clapping? What? It's a great place. It's really awesome. But I was at work one day. Woo, there it is. Go Oak City. Don't get me started on Kevin Durant. I don't even want to begin. But I was getting ready to go home one day to drive home from work, and somebody said, hey, you know the bridge is out by our house. And I thought, like, what, washed out? Like, what year is this? And sure enough, a semi-truck had gone under a major section of a road near our house and had completely collapsed the bridge. So it was like hours and hours of traffic to get around to try to figure out how to get home. But again, getting out and taking some pictures, knowing your reference, and kind of understanding what it is and being able to study what it is that you're going to build is huge, and you're really going to appreciate it when you're inside the interface and you start developing things. You'll come across these little tiny areas and you'll say, man, how was that little corner? Because in your head you see the big picture of the bridge, but how the one little arm comes in contact with the rail that's the handrail. If you can sketch that stuff out or have references for it, it's really going to help you in your procedural workflow when you're designing those elements. So anyway, yeah, it was a real bitch to get home for a week or two. So I also try to make some sketches. This is also a piece. What you're seeing today is actually a very whittled down section of what's going to be a much larger course, a Pluralsight course. So the sketches that I made for developing the course kind of look like this. Again, it was just an idea to get some more visual, work out some of the visual details of what that procedural model was going to be. And it also helps you to break down the elements. You can start to see exactly the pieces that you need to create. It doesn't seem as overwhelming to build this giant dynamic bridge system if you think, oh, I just need to start by building one of the supports. I see one of the supports and I see five on that mid-level, there's like 5 or 6 of the exact same thing over and over. Well, procedurally, I only need to build one of them. then I'm going to be able to use the procedural elements inside Houdini to create that entire structure to support the bridge. So again, just that sketching process to kind of break down how you're going to begin to build that asset. And again, I just had some from the side, little sketch as well from the side. Oh yeah, I don't know how much of this we're going to get into as far as today, as far as time, but yeah, I think in stupid American distances. So I did everything in feet first because it made sense to me. Little time-saving tip, there's a thing called Numerics Calculator. It's a Chrome plugin. It is genius. It has the best converter I've ever seen. So if you can go through like your sketches or your reference or whatever and kind of get an idea in meters, Houdini's default working unit is meters, and in most pipelines, in most situations, you're going to want to leave that alone. You don't necessarily want to change it up on your HIP file, and then somewhere down the pipeline, if you hand that off, somebody is working in meters and you designed it in feet. That's a real pain. So do the conversions yourself. Just fire up a calculator and do them all ahead of time. So when it comes time to build that element, you already know the units that you're working in are going to be the default Houdini units. So that's all. Same thing there. So let's take a look inside of Houdini at what it is that we built and how it all comes together. Now, I won't necessarily be building all of this live right in front of you. Again, we don't necessarily have time to go through all of that and explain all those concepts. I want to be able to show you the workflow and show you how that bridge is constructed and be able to stop and make sure that those concepts of the proceduralism are coming through. And if you guys have questions, man, stop me. Do not hesitate. Raise your hand, throw something at me, just not liquid because I like my laptop. But yeah, stop me and we'll talk about them. It'll be great. So let me just open up this scene real quick here. So here's the bridge itself that we're going to build, right? Again, I don't have time to put in all of the detail for this particular course of the multi-layered structures and the supports that we saw in the drawings and sketches. We're just going to kind of keep it isolated to this. But some of the benefits and what you can get out of using, again, that procedural thinking, that procedural design process, this whole entire bridge system is not that big. It's not that many nodes. We'll see the network here. That's really it. That's the entire procedural bridge system. It's just a few nodes. But one of them is this control node. And on this control node here, I put all of the relevant details that I want to be able to dynamically adjust about my bridge. So let's jump back here where we can see the viewport, and we'll just kind of see what we're working with. So the first thing is we have the section length. Now the section length is literally just the length of the individual span for that bridge. But notice as that length changes, we're not just transforming the points. We're not just like stretching it out with a scale modifier, right? Procedurally, as that bridge gets larger and larger, the spacing of where the handrails are actually is divided up evenly across the length of that bridge. And I'll show you exactly how that stuff is done. But we're not just like scaling the bridge to make it longer. We're actually changing some of the parameters that drive the location of where that handrail is. So it's not becoming an oblong, crazy shaped object. It's just scooting along. It's just moving its position. So like this handrail here, for instance. So let's look at some of the other procedural parameters that we have built in, though. So along with the section length, we also have a width, so we can make our bridge bigger and smaller. We have a lift, so we can actually make that bridge taller. If we had a very large bridge, we need to go over a big puddle of water, or we can make it smaller, whatever we want to do with that. We also have the ability to adjust the number of support columns that are inside that bridge. So if we go ahead and make it a little bit wider, we'll say we want an 8-lane or 9-lane highway there. We can just come in and give it more supports, depending upon how you want that design to look inside of your final render. All right. We have the road height, so we can actually make a little bit thicker highway or a little thinner one. We have the rails here, some things we can adjust on the rails. Zoom in on those so we can see those a little better. So we have the scale of the support beam for the rail. We can make them really tiny or giant. We have the rail height, which we can adjust. And the rail frequency, actually, will tell us how many different little support spans we're going to have across there. So we can add in as many of them as we want. And then again, we just have a simple adjustment for the thickness of the top support rail and the thickness of the bottom support rail. And with that, you can actually create several different bridge designs with just those few parameters in width and in size and height, and then copy that little section of the bridge across a line and make the bridge as long as you possibly want it to be, and be able to change all those individual little attributes of that bridge element. So let's go ahead and kind of start digging around a little bit inside of our network so we can see exactly how that is put together and how that procedural thinking kind of works for this model. Let's frame back up. The very first thing that we built, or that I built when I was doing this, was this profile, right? So this is just that support. And all it is just a curve. It's just a very simply drawn out the base shape of what I want that curve to be, okay? Now, one of the things, oh, yes, sir, go ahead.
Using a curve tool in Houdini, similar to the pen tool, just kind of drag drop points with anchors.
Very much so. Yeah, here, let's do just a quick little demo here. I can just grab a curve and draw it out however I want. We'll go ahead and close it. There we go. And then with the actual curve, you have options on whether you want that to be a polygon, which is going to give you tight lines, or NURBS curves. With the NURBS curves, you can adjust the points. So yeah, it's just a regular, fairly simple, basic curve thing there. So that's the base. The whole start is just that one piece of the leg right there. Now, one of the first things that we saw in the adjustable parameters was the ability to change the height of the bridge. So if I come back here and we look at the, nope, sorry. Oh, it's the section width. Yeah, okay. So I'm sorry, the section lift. So it's the ability to raise and lower this particular support beam element, so we could take the entire bridge and make it much, much taller or much, much smaller. Now, I could have done it with a simple transform, like by grabbing the entire shape and then just scaling it up and down. But when you grab the entire shape and just scale it, here, we'll lay one down here so we can see. So I'm just piping that curve into this transform node here. And I'm going to go ahead and scale it up a little bit so you can see what I'm talking about. If I just scale that thing, notice that you get that sort of distortion at the base, how the base is distorted, and you're going to get it at the top too. You get that distortion here. And that's not really what I want. I kind of just wanted to move that top section up in and of itself, like without stretching that bottom element. So the easiest way to do that was just to make a group. So I just went in here and said, all right, just these top points that make up that particular element, I want to make those a group. Those are points 3 through 9. Now, the way I know that is because I just turned on my point numbers and looked up here, and sure enough, there's 3, 4, 5, 6, 7, 8, 9. So I know those are the points that I want. Okay? So I can just say in my pattern for the points that I want points 3 through 9. If I have those in a particular group and isolated away from the rest of the geometry, now I can do my transform. And when I adjust my transform on my control for my lift, it's only moving those top points, and you don't get that distortion as you do in the shape in the bottom and the top elements. Yes, sir?
Just wondering, for the points, how do you make a group that it only uses those points? Is it just selecting them and making a group?
Well, there's two different ways that you can actually do that. The way I did it for this one was literally I just turned on my point numbers and saw that there was a pattern 3, 4, 5, 6, 7, 8, 9. I know there's 3 through 9, so it was just much easier for me to jump down there and go 3-9. And when it's, type it in, manually just type it in. I mean, you can make those. Let's see what happens, just for fun. We'll put in like 3 through 7, right? So now you see whenever I adjust my slider, I'm only moving points 3 through 7. 8 and 9 here at the bottom are not getting transformed. It's really just 3, 4, 5, 6, 7 here. But, or sorry, 5. I can't read. Yeah, thank you. 4 through 7. 8 and 9 here are not gathering, are not, the transform's not applied to them. So you can just type in 3 through 9. And now you get them all back in the group. So speaking of the proceduralism and the procedural nature, it's non-destructive, right? So I'm able to make this transform down here in the node that's a little bit below wherever that curve and that group is created. But when I change the group, any of the changes I make in the group filter down through the chain. So anything down below it, it's taking that information and just applying it and spreading it throughout the rest of the bridge. So the next thing that we did very easily was just extrude that column so you get this sort of distance, right? But you start to think, hey, that column's going to drive a lot of other elements. There's going to be a lot of things that are kind of dependent upon that distance. The handrail is going to have to be the same distance, right? The bridge surface is going to need to be that same exact distance. Everything's going to need to travel together. Well, one thing that I did when I first started building this was I knew that I might want to turn this into an asset that's used in possibly a game engine or in Maya or in Cinema 4D or something else, right? So I'm going to want a set of controls. The set of controls that we looked at before, all I did was create that set of controls and then start applying it throughout my network. So I'll show you how that's done here real quick. We'll make one of our own, sort of set up a custom one. So I use the poly extrude. We're going to start with just our curve. Okay, so this is just our curve that we built. Turn off my point numbers, a little bit easier to see there. Okay. And I just want to extrude it, no big deal. I'll grab the poly extrude. In the poly extrude, I say I want to transform the extruded front element by a particular distance, how far we want to extrude that thing, right? I'm going to use my global transform space so that my y, x, and z coordinates here will apply y, x, and z, so it makes sense. If I look at the outline here, I can see that I want to actually push it in the z direction. So all I have to do is come over to the z parameter, and I can start to get that distance. Right? So I'm just extruding it in z. Not that big a deal. The thing is, like I said, I have that one parameter that's going to drive the length of the handrails, the length of everything else. I just made a null. Very simply, just a little null node. And a null node is nothing. It's a null. It's just there. It just holds space. What I use my null nodes for is to build those controls. To build controls on any node inside of Houdini, all you need to do is make sure you have that node selected and go up to this little gear icon up here in the top right-hand corner and come over to Edit Parameter Interface. When you do, you get this separate dialog box. Now, this dialog box lets you basically choose what the end user is going to have access to. You can put anything you want here. Just like there's any number of attributes that you can create, and you can call them anything. Anybody was here this morning, we made an avocado attribute just for fun. You can do the same thing with your controls. So I'm going to select these two controls that we have here visible and turn them invisible. Now, simultaneously, watch what's happening over here. On that null node, we have this cache input and copy input. So here inside this new interface, we had the cache input and copy input. I just select them, make them visible. I'll go ahead and accept that. Now they no longer are visible on that node. It's that easy to add and remove controls. So let's add in one of our own, a custom one just for us. And I want it to be a float. Now that just means we're going to use a floating point number, a number with decimals in it, so that we have the ability to have incremental changes in what we want that to be. I'm just going to drag it over here to the interface. We'll drop it in, and I'm going to call this length. Right? Now there's two places that you need to change here, predominantly two very important places you need to change the information. Under the name where I said length, I left it all small caps, and you try not to use in this area any spaces or odd characters, and I'll show you why in just 1 second. The other thing you want to do is put a label in there. So now I have a label named length, and I have a name named length, and I'll tell you what the difference is right now. We can go ahead and apply this. I'm just going to scoot this window out of the way. Now on our null, we have this new thing called length. It's got a built-in slider for it that I can adjust. And notice there's a capital L on what you see in the interface, okay? That is the label parameter, all right? However, if I want to use this information to drive elements of another node, that's not the label that's being used, it's the name area. So here, I have named it length, and if you hover over that parameter and just let your mouse go for a second, it'll tell you what that name value is. So right there you can see that it's the small case L length. And just to kind of prove the point a little bit more, we can change this. Don't ask me why. I like avocados. So now we have length avocado in our interface, but if we hover over it, what we're going to refer to when we create scripts and when we start doing this procedural workflow is the name, not the label. We're always going to want to pull from the name, not the label. So it's just the difference between what the user sees and what the back-end procedural nature of Houdini sees. Let me take that out real quick. We'll go ahead and accept this. And now let's start to use that length parameter somewhere else in our network, right? So here we have our poly extrude. This is where we actually gave this little T-shaped support some depth. Well, I want to actually drive that using the length. So it's simple, piece of cake here. All we do is right-click on the parameter, we copy that parameter, and then we find the thing we want to change, right? So in this case, it was the extrusion in Y. I'm going to go ahead and just remove that. Right-click and choose Paste Copied Relative References. That's a long mouthful of stuff, ain't it? What that basically means is we're going to take a reference from the thing that we had copied, which was our length avocado that we made. And we want to copy that, and we want to say, I want to use that to drive this thing, but I want that reference to be a relative reference. And let's go ahead and paste it, and I'll show you what that means. Anybody here familiar with Linux? Use Linux? Unix, right? So relativity, relative paths, it's the exact same concept. If you're working around inside of a network and you needed to go up a file folder and then find a certain file, you'd use .. to get up a certain level. It's the exact same nomenclature, exact same thing inside of Houdini. So here, I'm using a channel expression, right? CH just means there's another channel in the network that I want to pull information from. You say, well, what channel is that? Well, .. right? Linux network, go up a level and start looking for stuff. So now we're out here in the world looking for it. We're not looking for it on this node. We're out here inside the network view looking for some kind of information. The information that we're looking for is located on the null that we created, and the thing that we're pulling in to drive it is length. And notice that's length with the small l. So this is what I was saying before. When you start using expressions and doing some of this procedural work, any of the parameters that you create, you're going to use that name attribute, not what's displayed for the user to see, but what you call, not the label, but the name that you actually give it when you create that parameter. Thing is, though, you don't have to know how to use all those expressions. I just copy-pasted that, right? And there it was. So that's pretty handy. Now that I've got that in there, I can come back to my null, and whenever I change my length here, obviously that value is getting propagated down into the extrusion value for that support. Questions, anybody real quick? Does that make sense? Is that making sense? Cool? Wicked. So now that we understand how the channel reference works and where those expressions are coming from and how all that information is getting passed around, we can move through the network just a little bit quicker here. So here's my single support. It's made the exact same way that we just showed, only instead of using this null of nothing, I'm using my control set. All of these parameters were made the exact same way that I just showed. I just went to the little icon, said, hey, I want a new one, and I'm going to use it to drive some stuff, right? So there's my single support. Now, how am I going to get multiple supports across the width of the bridge? I'm going to use a line. So here's just a simple line with some points on it, right? Well, there are 5 points. So there's 5 divisions there, 4 divisions, 5 points. The copy node is one of the coolest nodes that you'll ever work with inside of Houdini. And all it really does is say, I want to copy one of those supports to each point on that line, right? So now I've got my 5 points, or my 5 supports across there. But one of the other things that we saw in the control box was the ability to change the number of supports across the bridge. Well, I don't have to change the number of the supports across the bridge. I just need to change the number of points on that line. The copy node is going to say, hey, however many points there are on this line, I'm going to put a support on each one of those points, right? So here, inside of the actual width node, there's an option for points. How many points do you want on your line? And I'll show you this again just to be 100% clear on how this was all set up. I've just got a line. There's my line. There's the default line node. And the points, it's just a regular parameter. The more points that I put across there in that parameter, the more points I get on my line, which in turn means the more supports that are going to be copied to that point. So this was just a basic line that I put down, and I said, okay, I want to put some points on it. Once I do the copy, and I've copied those over, all I have to do is change the number of points, and I'm changing the number of supports. Well, the number of points here is actually driven by this thing called .c/column num, right? Well, we already know kind of how that works, right? .. tells us to go up one level and start looking for information out here in the world. My controls node is called C. And the number of columns, if I hover over it, wait for just a second, I get the little pop-up that tells me that's column underscore num. All I did to get that down there, literally, right-click, copy, came down to that particular section where I wanted to drive it, right-click, paste copied relative references, and that was it. So literally a copy-paste, make a new parameter, copy-paste, put it in place. Now I'm driving 5 different pieces of geometry with one slider, and all it was a copy-paste operation. Thank you, Houdini. So let's go ahead and kind of go through our network just a little bit further, and we'll kind of look at some of the other procedural network, other procedural elements that are being set up. So based off of that line, just that one line, that's all it is, one piece of geometry here, I was able to give it a little bit of height. Again, that's just a poly extrude. We saw how the poly extrude works. You just go in X, Y, Z, which direction do I want to extrude it? I said, hey, I want to take that line and I want to extrude it up a little bit in Y to give me some depth, right? Now from that depth, I said, well, I want to give it a little bit of length. You see what element we're building now? We're building the road piece, right? So the road piece has parameters that we saw that I can change how thick or how thin that road is. Well, if we look back here, that very first extrusion that we made to give it that extrusion in Y was, again, something on my control node called road height. So all I did was edit the interface on my C node, make a parameter called road height. There it is. Or no, that's rail height. Where is it? Road height. Made a road height, copied it, pasted it, move along. Next step. Let's keep going. I mean, it's that like easy to start thinking procedurally and start using this stuff this way. So I've got the height determined by something that I have control over. The width, however, is already controlled by something I've already set up. I mean, I want the extrusion of the supports to match the same extrusion of the road height. Well, just use that same one again. Right here is the section length. That's the exact same thing that drives the distance of the extrusion on the support. That same value, that same slider, that same set of information is now driving the extrusion of the road. Okay, so one thing doing multiple tasks throughout this giant network. And it's not even a giant network, it's just a decent network. It's a cute little network. The next thing that I want to do is if we look at where the position of this particular road is, we say, well, that's sitting at the bottom of my supports. That's not exactly where I want it. I want it to sit at the very top element of my supports. Well, thinking procedurally again, I could go in here and I could just grab it and use a transform node and I'd be able to scoot it up manually and say, okay, yeah, that's about where I want it. But then what happens whenever I change the height of the rail, right? So I've told the bridge manually, this is where I want you to be, and then I'm moving all this stuff underneath it and it doesn't know to accept that information and use it to push that road where it needs to be to match the top of the supports. Well, very easily, the simple way to do that is to use a bounding box expression. The bounding box expression takes a single piece of geometry in your network. It could be anything. The phone. And it says, here's my phone, and I've got an outline of your phone. Now, it doesn't matter what's in it. It could be a character. It could be a complex character. It could just be a box. It doesn't matter. But whatever's in it, I'm going to draw a box around the ultimate extends of that object. Okay? Now that I know what that box is and how big it is in height in X, Y, and Z, I can put something on those bounds anywhere that I want to put it. So I could say, hey, I've got this mouse, and I want the mouse's position to always be at the top of the bounding box of my phone. Now, no matter how big my phone gets, taller or smaller, or where it is in the world, that mouse will always be stuck to it. If I would have manually gone in and said, okay, I want to transform my mouse here, and then whenever I change the phone, the mouse won't go with it. So what we did here is simply take a bounding box of the supports. Now again, think about how we discussed this as sort of a Linux operating system. We're going to go ... // so we go up one level. So now I'm out here in this general network looking for some piece of data, right? What I want is the bounding box of the supports node. Well, here, where I copy all of my supports, I put another null. So all this node is the result of those copied pillars across that line. So I just drop a new null. Literally, I can, and I'll show you this real quick. This is a neat little thing. So I can call that null anything. Yes, of course, you know it. So I can put avocado over here and go like this, because that makes more sense to me, right? I know what that is. So when I'm building that expression for the bounding box, which can get a little, maybe frustrating to remember exactly what it is in your scene you're looking for, right now I'm looking to this supports node to get it. That means that it's coming down and looking to supports. The null node, again, does nothing. It's nothing. It's a placeholder. It's like sticking a bookmark in your network and saying, go to that place, okay? I could get the exact same result if I would have pulled it from transform 3. Okay, the bounding box of the objects at transform 3 is identical to the bounding box as it is on this supports node. It's a null. It doesn't modify anything. It's just that when I'm writing that script, man, okay, I want to put it on transform. There's like 50 transforms in my network. Which transform do I want to put it on top of when I'm making the bounding box expression? I'll just call it something I know. Let's go put it on supports. Cool. I put a null down, call it supports. That's what I reference inside the expression. Okay, I saw a couple hands. How are we doing? Questions? Yes, sir.
Bounding box, is that just like an expression, like a CH or something?
It's exactly what it is. It's exactly the same thing. The thing is, Houdini gives us a really cool way of doing that channel-driven idea, the CH expression, by just copying something and then pasting that relative reference, and boom, it puts it in there. All it's doing is it's writing the expression for you, right? For the bounding box expression, there's not a simple right-click methodology for that. You kind of have to know, I want the bounding box information, and I'm going to put something on top of it. Now, there's a great resource that I'll show you here as we start to wrap up near the end. There's an expression cookbook inside the help, and there's a list of all the expressions that you can filter through and see exactly all of the tools that you have access to be able to write expressions and do fancy expression stuff with, and it's great. If I don't, for some reason, somebody say, show me that, and we'll make sure and look it up, and I'll show you where it's at. But there's an incredible amount of really cool procedural expressions that you can use in your modeling with things like this. But yes, that's exactly all it is. It's just an expression, just typed in. So again, here I made another null, and this null is just bridge base. And I did that because I know that sometime later I'm going to call that back in an expression. And it's going to be a lot easier to know where my bridge base is if I call it bridge base instead of calling it merge 1. There's a bunch of merges in this scene too. It's going to be real hard to find where that location is. So it's just a bookmark. This particular spot in the network marks all of the elements that make up the base of the bridge. I know where that is. Cool, I can get to that very easily. The next part of the entire construction of that particular model was to start thinking about how those rails on top were built. So for the rails, all we did was, I keep saying we because I don't know, it's just me. I don't have any idea why. So the Rails support profile is literally just a grid. So if you would just come in here and laid down a regular old grid geometry, that's all it is. I just shrunk down the size quite a bit. This grid is only 0.5 or 0.05 by 0.05 in size. So it's just a little grid, no biggie. And then I want to scoot that grid around just a little bit, right? So to do that, I'm going to use this transform node, or not scoot it around, I'm sorry, actually be able to scale the size of it. What we're building right now is the piece of the handrail in the controls where we were able to change the thickness of those handrails. So all those handrails were based on, the support for it was based on this little grid that we're going to extrude to make a little stick. Well, I want to be able to make that thicker and smaller, so all I did was use a transform and the uniform scale. And then again, here it is, just a repeat. //c, go to my control and pull that custom attribute that I made, or custom parameter that I made called rail support scale, right? And you can see it back here. Now if I just take rail support scale, all I'm driving is the size of that base grid. That's all it is. Next thing that we do after we have the size we want is we extrude it. All right, cool. So what we're going to do now is have a series of these along that handrail. Well, just like we had before where we had a series of the supports along the line and we changed the number of the points and then copied those supports onto that line, we're going to do the same concept here, but a little bit different, but the same concept of using the copy node to put those little support rails along the top of the bridge. Okay? So this gives us the size and shape of our little support, which is awesome. Over here we have what I call the rail base profile. Again, it's just a grid. We just made a grid, and we're going to extrude that grid. we're going to make a long piece of it that is the exact same length of what the length of our supports and the length of our road is. So yes, I use the section length call right back here. Just same thing again, just plugged it into a different spot. Okay, after we did that, I need to have a way to copy those little handrails across this piece of geometry. Now the problem is that that piece of geometry is going to change in length. And I want to be able to have those handrails dynamically change whenever the length of that object changes without getting stretched out. So the thought process here was, what if I had a point, a single point that exists in the middle of each of these primitives, right? And I have the ability to change the number of divisions along that rail. Well, if I have a single point, I can use the copy node and copy that handrail onto that point. And then all of a sudden, I've got my proceduralism. I'm no longer stretching things and transforming them. I'm just copying my individual support rails onto those points. So let's go ahead and make that happen. So as we come through the line here, this is our support rail. I go through and I just deleted all three sides except for the very top piece. All I want is that very top section because that's where my rail is going to stick off of. And here, let me do this. This might be a little... Keep in mind, this stuff is being built at the center right now of the scene. It's just default geometry in its default position. Once we get it built, modularly built, the handrail, then we'll push it up and over and put it over into spot, okay? But what we're building is this element here of the handrails. All right, let's hide that. So here's the process that I use, and I know there are other ways of doing this in code and Vex and VOPs and all kinds of crazy terminology that Houdini uses. I got rid of everything except that top series of primitives, so I just deleted it, selected them and deleted them, literally in the viewport. Just grab it, hit delete, boop. All right, undo that. That made that little delete node, and I got rid of everything except those top pieces. Those top pieces, those top primitives, I'm going to convert those into circles. Now that seems a little odd at first. You're like, that makes no sense. There's no circles in there. Well, what the circle is it puts a single individual primitive with a point dead in the center of it based off of whatever that polygon was that's on top. Now, what does all that mean? Let me show you. So here is the handrail before. No point in the middle whatsoever. I'm going to take each one of those little faces, those primitives, if you will. We're going to turn them into circles. The circle does have a point in the middle. I can now use an add SOP. All the add SOP does is it says, get rid of all the geometry and leave me only the points, right? So now what I've done, if we look at everything put together, go back here and we'll template this guy. I now have a point that's located in the center of that top face, dead in the middle. No code, no Vex, no VOPs, no nothing. 2 nodes. Take those faces, make them a circle, use an add node, delete the geometry. Point in the middle of a face. Awesome. Now, I've got my points. Just like when we made the rails, I can copy that handrail onto those points. So again, we're going to use a little copy node. If I can find it. There it is. So what that does is it gives me my supports. Now I've got these supports that are located directly in the middle all the way across that rail support. I've got my vertical supports for that rail base. Now I have the ability to turn off points so it'll look a little bit better. And we know the thickness and width and size of these handrails is controlled by one of our controls up top. Again, that was a copy-paste channel operation. So the rail support scale, right? That was the grid. I'm just changing the scale of that grid. That's all there is to it. Now, the rail height is just an extrude. That's all it is. It just extrudes that and extrudes that grid straight up. No big deal. Right? Copy it from here, paste it into your poly extrude. You're extruding that way. The magic kind of fun part here is when we start talking about the frequency of the rails. Now, the rail frequency can change because the divisions of this original support are changing. So think about that. If I have 2 divisions in that rail, my procedural network comes down here and it says, okay, well, I need to make 2 circles, and then delete the geometry from those, which will give me 2 points, each one still dead in the middle of the face of that base rail. So what I'm changing really is not the number of rails. What I'm changing is the number of faces that are on top of this support system right here. That's done in the extrude right in this spot. So when we make the extrude, the initial extrude, we have the ability to change the number of divisions that are in that extrude. As I change the number of divisions, I create more little polygons, and I get more little dots in the center of those polygons, and therefore I copy my handrails on them, so I get more little handrails across the top of that bar. So again, this is part of that whole thinking procedurally idea. It's not, I need to make a handrail, and I need to make 5 of them and move them into place, because that's not going to change dynamically. When you go in and say, I want my entire bridge scale to change, you're going to have to go back and change that for each one of those little support rails if you want it to follow and match along, right? Old school, like other software I don't like to talk about in public thinking, right? Think procedurally. Think, how can I do this modularly so I can get this in a way that's going to be dynamic and change with me and change for the environment and change for what it is that I'm trying to build. So we're about to finish up the handrail here. Questions at this point? Are there more questions? Yes, sir.
So, in the where you have the channel for and actually thinking back to the bridge supports,
Yes, sir.
possible to put like a formula inside there where you can actually just say like, give me the ceiling of the length divided by 5 is the number of supports. It seems like they're roundabout way of calculating middle points. Or is that not possible?
You mean to get the center of the face here on this particular piece?
Let's say the bridge supports example where you actually have that setting the number of points in the line.
Oh, yeah.
Would it be possible to say like the number of points is equal to the ceiling of the length divided by 5?
Yes. 150%. And I'll show you a really simpler kind of explanation of that exact thing. The position of this line uses something very similar to that. In fact, really simple version of it, but what happens here, I'm going to take this, we'll just cut this out. So the line is created by default at the origin, so if I look at my grid, it starts at 0, 0, 0. But I don't want my line to be there, because then when I take my bridge and say I want it to be wider, it's going to push it off to the left. And I want it to expand from the middle and grow out equally on each side, right? So instead of that line being positioned there, I looked and I said, how long is the line? Regardless of how long it is, I want to take that distance, divide it in half, and then scoot it back in the X direction so that it's at the center. And that simply was that. Take the channel of distance, which is the length of the line, divide it in half, and then negatively scoot it back. So now, once I have that applied, the line exists in the middle, no matter how long the line is. It could be 8 feet, it's going to move it back 4 feet. If it's 2 feet, it's going to move it back 1 foot, right? The expression is saying, look at the distance, cut it in half, scoot it back, regardless of what it is. So yeah. Does that help?
Yeah.
Sorry, I forgot to mention again for the recording. The question was, can you use expressions in fields? So there we go, in parameters. So there we go. Okay, so the last little bit of this we're going to wrap up here is just setting up the top rail and the side rail. For the actual rails, let me turn off my templating, get back here. So all the rails are these circles. So I just took a circle, and I said I want a smaller one. So it's a really tiny little circle. And then I want another tiny little circle. That's the second element of the rail. So I've got 2 of them going here. They both get extruded. Guess how far they get extruded? The section length, so that it matches the length of the bridge, length of the supports, length of everything else. So we're pushing that data again through another part of the network. Then those get transformed or moved around, but instead of doing it manually, scooting them over and placing them where they are, if I put them on the handrails and then I made the thing wider, I'd have to go back again and say, okay, I want to move those again so those match. No need to do it. I use a bounding box. I say, why don't you just look at the rail supports and stick them on the outside. Here's the rail, here's the circle, stick them on the outside. Now, if I make that bridge wider or smaller, that rail is always going to be in the bounding box of that particular position. Doesn't matter. It's just reading numbers. It's just manipulating the numbers. So that gives me my rails. Big rail, little rail. Merge it all together, and this is my rail system. After you have the rail system, I just copied it twice because I want 2 of them. And then I took each copy and said, okay, that first copy, put it on the bounding box of the outside of the bridge in X, right? The second one, do the same thing, but do it negatively. So take that rail that's at the center and put this one on the bounding box of my bridge. Imagine this is my bridge support, and this is my rail system. Put it over here. The next copy, take it and put it over here. So now I've got a copy of that rail system sitting at the end of the bounding box of that bridge support. So now when I make my bridge, this is silly. Now when I make my bridge wider and smaller, those rail systems are always sticking to the edge no matter where it goes, they're sticking to the width of that bridge system. And then just kind of bring it all down to the bottom, make it look pretty, and give it some controls. Well, good, because I'm done. But that's it. That's the idea. And again, I didn't necessarily mean for this lesson to be take notes so I can go home and build a procedural bridge just like that one. We can't handle that in this amount of time. We just don't have the time to go through creating each node by scratch and being able to build it all the way out. I really wanted to get more of that concept of procedural modeling and proceduralism and how it works and how powerful it can be inside of Houdini. Start thinking procedurally. Instead of manually moving everything everywhere you need it to be, use Houdini properties and your own custom controls, very simply made in a couple of clicks, to drive all those parameters inside of your model. You'll get a much more dynamic model. All right, questions? Anybody? Anything? Oh, here we go. Yes, go ahead.
So you're using curves for input, and that's really cool because you can easily manipulate things. But like if you have a bunch of traditional artists you're working with, maybe you just want to like pipe in some base geometry from somewhere else on a disk. Is it possible to like throw like a file selector into a node to be able to like just browse through geometry?
100%. Do one? Oh, right, repeat the question. The question was, can you use anything that you need for inputs instead of just curves? Could you use geometry from disk or other elements? And the answer is 100%. All you need to do is just wire them into that particular position. Right now I'm using that width line to drive the position of basically the width. The entire thing is based on that one width curve. If you had something off of disk, you just use a file node. And the file node has a browser, and you say, okay, I want to browse and find whatever that piece of geometry is.
But could you like point that to a library of parts? Do I have to go out to the file system every time, or can I just create a drop-down, for example, with a bunch of themes?
Yes, you can. That is way more into the digital asset building concept. Right now what we've got is a bunch of nodes in a network that you have to browse around and kind of look for. But the concept of a digital asset would be this set of controls that exists on the C would be right here at the object level. And you'd be able to like go tab, bridge, boom, it drops down this node, and there's all those controls that rest on the outside. You never see the inside whatsoever. Once you get the tool built, you hand it off to an artist that needs to build bridges. They just go bridge, wider, smaller, more supports, less of this, multiple rails, move on. Next, I need to build another bridge, new bridge, more supports, less so-and-so. So they're not having to go through and deal with all of that. And yeah, you can easily, when you build that as a digital asset in that box, when you create that, which we'll kind of go over in this next class, a different example, but it's about building digital assets, so we'll talk about that. You're able to choose what you have in that interface. And yes, you can easily take a drop down and put geometry in there if you wanted and just pick that piece of geometry. So maybe you wanted to build a circle bridge, right? So you have a default circle, you choose the drop down, choose circle, it puts a circle in there. Another one, boom, puts another shape in there. So you've got all these different presets that you can kind of work with. So yeah, that can be done. Other questions? Yes, sir? Not really. It's not like those other softwares I don't like to mention in public. So the reason that works that way, that there's not, what do I have? Do I have 49? I got 2 minutes? 2 minutes. All right, 2 minutes. So here's the difference in Houdini Think versus that other thing. I'm going to start with just a simple piece of geometry here, just a geo node, and let's put a sphere down. Everybody loves a sphere. Guess I could have done a teapot. All right. So here's a sphere. So when you think about something inside of that other thing, whenever you make those changes and you move something or you modify something, it's storing that information somewhere, right? And you call that history. So it's got a history of things that have happened to it that you can remember in the past and call back or delete or remove or whatever you want to do with. When you do that same thing in Houdini, you're actually just putting down different nodes. So if I want to move that box, I can jump in here and say I want to transform the box. Now I can move it. Next thing I want to do to it might be add some color to it. That's something that I want to do to that thing. So I can take it and I can add a color node. Now I've added, if I can type, now I've added a color node. After I do that, maybe I want to transform it again. So I'm going to go ahead and transform it again. This time we'll rotate it around a little bit, right? So let's come in here and we'll just spin it. So we've spun it in 25 degrees off of its original axis there, right? We can do it manually here. Everything doesn't have to be typed in with nodes, guys. You can use any of the tools in the viewport, and it's going to, in the background, start creating those nodes. Those nodes are what you're calling history. So instead of there being this invisible thing that you can't see called history that you have to dig 9 levels for to find out what it is that you did, or Control-Z, 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 Control-Z to get back to it, as you build and move and manipulate geometry inside of Houdini, this is what you would call history from that concept. This is everything that's been done to that piece of geometry. You can remove stuff from the middle. Try to do that in the other thing. Take a section of history, not the whole thing, just one little bit of that history, and get rid of that. Not the whole entire history. I don't want to collapse the whole thing, and I don't want to undo, because then I have to redo these two things. I just want to get rid of that one thing. Just drag it out of the network. It's no longer a part of the history. Yes, sir? By mergeable, do you mean can I load one HIP file into another?
When you know, more like, can I have two people working on the same file and actually merge those histories?
Oh, yeah. Yes, the question was, can we merge histories from 2 different scenes or from 2 different users or 2 different artists? Can you take that information and put it together in one scene? Yeah, it's several different ways you can do it. The really easy, silly, manual way is copy-paste it, man. I mean, it's that easy. All this stuff that's happened in here, this modify, these 2 transforms, the color, all that stuff, all I have to do is take that node and copy it, and where's my other instance? I just launched another instance of Houdini. Paste that in the network, and it's there.
You're going to be diving into tool building, which is great.
Yeah.
That's a good segue.
So boom, there it is with all its stuff. All right, I think we're going to give some stuff away. Who wants free stuff? Woo, swag! Let's do that a little bit. I'm going to take a 2-minute while they do that.
So it's 1:53. We'll have 7 minutes until